Okay, we were talking before yesterday, we were able to graph these and look at the graph and trace them and try to figure out what the value is going to be. But I also told you we don't want to know what it is right at that point. We want to know when you get close to that point. So we talked about how you can put it into the equation and it's going to tell you what it is right at that point. But then we said if we put it into the top equation, we got a value of 1. If you put it in the bottom equation, we got a value of -2, and those don't meet each other, so therefore the limit does not exist. Whether I had a graph or not, the two values from both directions did not come to the same value. So if we look at this one, the easy way, instead of having to graph these all the time, because I left you with the thought, how do I graph that, to try to look at the graph and trace it to 2 to see if my fingers meet up at the same spot. So what we can do instead is the same thing I just talked about with the last one real quickly, or what we were kind of looking at yesterday, is what happens if I just put 2 in 4x in my limit to see what it approaches. Because the ones you worked with in section 1.5, you put 0 in for h, which h meant delta x. H meant delta x, which meant the distance between those 2 points, and we wanted them to hug each other, so we wanted that distance to be as close to 0 as possible. So here, we put 0 in for h, and it didn't give us, it eliminated some terms. Now we're going to put 2 in, and it's not necessarily going to eliminate terms, but it's going to give us a value. And that's okay. That's what we want. We want to know, what does that approach? That's what you do when you talk about a limit. But the problem with this one is if I put 2 in, you get 3 times 2 squared, which is 12, minus 2 times 11, which is 22, plus 10 over 2 minus 2. That gives you 0 over 0. Now, what is 0 over 0? Indeterminate. We cannot determine what that value is. But what we can do is simplify that blue expression. We can simplify it by factoring. Now you got to dig deep. Remember your factoring from at least algebra 2, you had to factor. So we got to dig deep and remember our factoring. How does that numerator factor? Well, 3x and x, are the signs the same or different? The same. Are they both positive or both negative? Negative. Multiplied together give you 10. The outer and inner have to give you 11. So what are the values? It's either 10 and 1 or 5 and 2, right?
Three times 2 is 6.
Here's one thing that's going to help you. Is x minus 2. We can't just say added together, give you the 11. Why can't you? Because one of them has a coefficient of 3. So what did you say?
3 times 2 is 6.
You go with the outer gives you negative 6x. The inner gives you negative 5x. And when you group those together, you get negative 11x. So that's the numerator factored. The denominator, let me get rid of this for a second so I can write below there. The denominator has a value of x minus 2. When I look at that in factored form, what happens? The x minus 2's can cancel. Now, this is going to be a key thing, and I can't stress it enough because I helped Jennifer Donnell, now a lawyer. Everybody know Jennifer? She took, okay, Linda Donnell that does your, it's her daughter. Okay, so she was going to take calculus at UNL. So the summer before she took it that fall, she asked me if I would tutor her. So she had purchased the book ahead of time, knew what book she would have. So I helped her during the summer, and I said, you better write limit in each step when you do the limit problems, or you're going to get it wrong. And I get a text message back that fall. You're right, Mrs. Sheds. you have to write limit or you get it wrong. It's a big thing. So as you go from one step to the next step, you need to write the limit. So what we have now is the limit as x approaches 2 of, and I really probably should have put my 3x minus 5 times the quantity x minus 2 over x minus 2. And the x minus 2's cancel. And I know I have to write it as well. So, and I had to write it as well in college calculus. So I know it's a pain. You are asking for the limit as x approaches 2 of 3x minus 5. Now that you're going to do that substitution process, I can just say it's going to be 3 times 2 minus 5. And what does it approach? 1. Your answer is 1. You're substituting in, so it's no longer the limit. You're actually replacing for the value. So you do not have to on that final step. But it's a key thing that you write limit every single time. Okay, it's probably just like the label. You just can't say, hey, shots. You're supposed to say Mrs. Shots because the administration doesn't like that. Okay, question on that one. Look, we didn't even have to do the graph. You could probably type in the graph, go back in and see if you can't enter this into, okay, does everybody know how to type that in as a graph on your graphing calculator? I'm going to do it too. I'm going to pause this so we can do. All right, the next example. Before you factor, because I will tell you, sometimes you're going to get 7 over 0. If you get 7 over 0, factoring is not going to help you at all. Because what's 7 over 0? Undefined. What would a graph that says undefined look like? Piecewise function. Does the limit as x approaches, would the limit as x approaches 3 exist here? No. Now I realize that's not specifically a piecewise right there, but that's what can happen when you're looking at some. That's a possibility of what could happen. So we got to be careful when we just say factor, because sometimes you might just have 0 over a number and it's going to be the answer 0. Factoring doesn't always lead you to, I mean, that's not the first thing you always want to do. The first thing you want to do is substitute it in and see what you get. You do not factor unless you get 0 over 0. So if I put the number in, so that's the first thing I could do. I could substitute in 3 and I do not have to put the limit because I am putting that number in. So that's how I can get away without writing the limit. So I'm going to have 3 squared minus 3 minus 6 over 3 squared minus 9. So you get 9 minus 9 over 9 minus 9. And we do end up with 0 over 0. When you get 0 over 0, indeterminate, now yes, you can factor. So I'm going to factor. So once again, I'm sorry, but you got to write the limit as x approaches 3. So I'm going to factor the numerator. How does the numerator factor? X minus 3, x plus 2. All over. The denominator is the difference of perfect squares, so it factors into the conjugates, which would be x minus 3 times quantity x plus 3. What happens? The x minus 3's cancel, and sometimes this gets kind of messy. You've got to be neat with your assignments still because you're getting into stuff here. Now we got to take the limit as x approaches 3 of x plus 2 over x plus 3. I can just put my equal sign without having to write limit again because I'm going to replace. And if I substitute in, what are you going to get? 5 over 6. And there's your answer. 0 over 0. Only factor if you get 0 over 0. If it just equals a number, then that's your answer. Yep. Quite a few of them, but no, not quite all. Okay. The next thing. Now what I want you to do is you turn to page, well, okay, just turn the page right away and look at 52. Justify each step by appealing to one of the properties of the main limit theorem. What they're having you do is they're having you break it down into individual parts because of rules that work when you talk about taking the limits. The end result will still be the same as if you just substitute the number in without doing each individual separate part. Looks like a lot of work right there when you were talking about, okay, so if I were to look at example F, what happens when you take -2 and raise it to the 4th power? What's that have a value of? 16 times 3 is 48. And then you're going to get -2 times -2, which means +4. And what's your answer? 52. Okay, we just did that one mentally. Look at all the work they went to get to that answer. Now, what they are asking you to do on problems, let me find it, 31 through 42. First of all, on 31, is the second factor x squared plus x minus 1? Does that show up on yours? Okay, because I had to write it in on my book, and I was hoping we copied it off of my book, and you guys see that -1 there. Did they come off pretty dark so you can read everything? Okay, I was hoping so. It's been a while since I copied them. What they want you to do on 31 through 42 is break it down into all of the little steps until you get to limit as x approaches a number of just x. And it's not very fun. We're going to talk about it so you understand it, but we're not going to sit there and do it every single step. And what they want you to do is they want you to justify every single time you do it by turning to page 51 and putting the number of which one it corresponds to. That's why you do it, is because number 5 says that's what you do, or because number 6 says that's what you do. And they want you to get every single one of those limit problems down to either a 1 or 2 by using steps 3 through 8. That's time consuming, and yeah, that will take a little while. So we're going to get the gist of it by looking at just the main limit theorem and some of those properties, but we're not going to do all of them. What time's the bell ringing here on the day like today? Oh wait, I took a picture on my phone of the schedule so I can figure out when it is, because this is going to take us a little bit.